Okay, they are joining.
Okay, good morning to all the attendees. In that case, we are in a workshop in order to develop the different developments in the Merlin project. This is a project that started in 2020, if I'm not wrong. This is a project of 3 years, and we want to speak about the different developments in the World Package 1 that is regarding the different technologies in order to improve the developments related to sorting and the different separation of the flows of multi-layer packaging. So to start, I go to share my screen in order to start with a main overall of the project. So this is the presentation, okay? So just to start, sorry because I didn't introduce me. I'm Francisco Sanchez. I'm from Spain, from ITENE. That is a technological center in Valencia. It's focused in different projects related to the innovation and the improvement of the recycling of the different technologies regarding the packaging. In that case, this workshop is named Merlin Unveiled, Revolutionizing multi-layer packaging sorting in industrial settings. And I'm gonna start with this first overall of the project in order to introduce you to all of you to the project. So the name of the project is Merlin, increasing the quality and rate of multi-layer packaging recycling waste. The goal was presented in 2020. I think that the project started, in 2021. And the goal of the project was improving the sorting, separation, and recycling of composite and multi-layer material. The project is expected to have 36 months of duration. The budget was 4.9 million euros. They are working in the different tasks in this project, 14 partners from 7 countries, and it's a project that is a research and innovation action. You can see in the map of the slide the different partners involved in the project, and there are from different companies related to the sorting, the delamination and recycling, the service providers, and from the packaging industry. In this slide, you can see with more detail the different partners involved in the consortium of Merlin. There are 6 SMEs, 4 technological centers, 1 non-profit company, and 3 large companies. And as you can see in the image, there are from these 7 countries: Germany, Belgium, Croatia, Spain, France, the Netherlands, and Italy. So this is a brief summary of Merlin. When we started with the preparation of this project, we achieved we detect the problem that was presented related to the related with the packaging waste in Europe. As you can see in the slide, the post-consumer packaging waste in the European Union is about 14 million of tons per year. This is a data from the year 2018. The recycling rate is 42%. I mean, the 42% of the material of post-consumer packaging waste is recycled, but more or less 14% is valorized by each generation, and almost the 20% is sent to the landfill. What is the impact of all of this? The economic impact is more than 10,000 million of euros, and the environmental impact of not recycling all of this quantity of waste it's more than 7 million of tons of CO2 that is sent to the atmosphere. And in that case, in this project, we are focused in the main fractions of multi-layer sample, multi-layer fractions in the industry. The first of all, there is the rigid multi-layer packaging. That's the trays where we can introduce, for example, meat or fish. In that case, the main structure of this tray is the PET PE. The second flow is the flexible packaging, the film. We are working in the optimization of the recycling of the PET and different polyolefins like polyethylene or polypropylene. And finally, the final fraction to optimize the recycling is the metallized flexible packaging, that the main structure is a PET, a layer of metallized, and finally, different polyolefins like polypropylene or polyethylene. The question is, why multi-layer packaging? Why we select this multi-layer structure? First of all, because it's a type of packaging that is widely used due to its high performance. It's used because in more cases, the different products need more than one layer, and in that case, we need to introduce different layer in order to be, for example, barrier to the oxygen, layer to the moisture, and different applications. And it represents 17% of the packaging that is produced every year. Another point is that the identification in plant is complex and inaccurate. For this reason, in that case, in World Package 1, we improve the different technologies in order to separate in the different flows the material in the sorting plant. Of course, the different natures of the layers, for example, the PET, PE, that makes the recycling of these structures very difficult, and may, in more cases, if in order to process these materials is needed an additivation, like, for example, introducing chain extenders in order to create this improving in the process of the improvement in the process of the material. And finally, in order to increase the delamination of the multi-layer, because every structure have a different adhesive, a different structure, and it's very important to improve the delamination of this structure and improve and optimize the delamination of a mix of this structure in order to have the optimal conditions in order to separate the different layers in a different mesh of structures. Well, this is the summary of Merlin. Merlin overall objectives is the development of new sorting, delamination, and recycling processes for both flexible and rigid multi-layer post-consumer packaging in order to produce this new packaging solution for food packaging application. As I say, we work with flexible and rigid packaging, and you can see in the scheme of the slide the main developments separated in the different technical work packages of the project. In that case, in that project, the technological issues are developed in 4 main work packages. As you can see in the image, in gray, we have the sorting and packaging identification. That is the main focus of this workshop. In that case, this technology will be explained by my colleagues in the next presentations. There are different developments related to hyperspectral imaging combined with photonic techniques, the artificial intelligence in order to program the different robots in order to separate the different multi-layer structures in the sorting plant, and finally, industrial proof of concept in order to separate the different materials. The next link of the project is the delamination, separation, and recovery. There are 3 different lines: the selective depolymerization of the PET from rigid multilayer, the delamination of the flexible packaging, in that case is the non-metallized packaging, using traditional and green solvents. In that case, is a task that is developed mainly by ITENE, and we are working with traditional solvents and, for example, an innovative technology like the supercritical CO2 plant, supercritical CO2, in order to delaminate this type of structure, and finally, the solvent-based delamination for metallized flexible packaging. The third work package of this project is the recycling, the recovery, and the reprocessing of the material. In that case, the different scraps obtained from the film and the monomer obtained from this selective depolymerization of the dyes are processing in order to obtaining the final pellets. That this pellet maybe is needed during the process and additivation in order to create a pellet with a high purity. And in the last of the work packages is the validation of the project in order to close the loop of the recycling. And in that case, we are working in the creation of different prototypes, like a pot, like a tray, like a bottle, and a film, a multi-layer film, in order to evaluate if this upcycling of the process is validated. We have another transversal task, like the safety assessment of these new packaging developments, and finally analyze the circularity of these demonstrators in order to check if the quality of all the process is assessed. In that case, we have a global explanation of all the technical developments, and also the different transversal information obtained with this project. As you can see in the center of the scheme, we can see the different technical developments. As I commented previously, the identification and the sorting of the multi-layer packaging, followed by the different delamination processes, and finally the processing of the material obtained, and finally the generation of the prototypes and the validation. And you can see as a transversal issues the food contact safety analysis, the circular by design, the recycling cycle analysis, and the knowledge generation, and finally the life cycle analysis and the human safety analysis. It's important to comment that all the technologies is important to be clear that the developments are ongoing, but of course the different transversal issues are of course they have a bigger importance, because without this we can take the general vision of the different developments related the project. This is the contribution to the European Union of plastic strategy with this project. We have different, as I said, pillars in order to create technology and create information to the companies, and finally contribute with this development to the recycling of this type of structures. We have to expand the emerging smart waste management sector, introducing smart technology in sorting plant. Is the main objective of this workshop, just to explain this type of smart waste management optimization of the sorting plants, the delamination of the multi-layer structure in packaging with the rigid, flexible, and the metallized flexible multi-layer, to improve the properties of the recovered material, the PET and the PE, in the processes of the different flows, and and produce a new packaging prototype to value retention in the economy. And you can see in the center of the slide the main objective of the project, that is develop and promote new sorting, delamination, recycling, and validation processes for flexible and rigid multi-layer post-consumer packaging in order to produce new packaging solution for food packaging. In that case, what we are looking for from the companies or from the different stakeholders related to the recycling of the multi-layer packaging, we are looking for industry inputs on Merlin developments, just to achieve the validation of how Merlin is in accordance with the European legislation, the current European legislation, because you know that is in a perpetual change. The input from policymakers on where legislation is heading in the future. All of this will be and is evaluated during the process. The extrapolation of the value chain for another type of plastic waste, because maybe the optimization of the process and the process obtained during the project are focused in just one type of structures, but maybe it can be extrapolated to another structure that can be improved also their circular economy, and in order to improve their recycling and processing. And finally, we are looking for adding new members for the advisory board in order to increase the feedback between the different partners involved in the project and the different companies that can be interested in the different process and the different developments obtained during this project. You can see in this slide the different social media that we have related with the project. We have a website, we have email, a LinkedIn account, and a Twitter account. And it's very important to be connected with the project. And if you are interested in order to follow the different information related with the project, it's important to follow these different counts. And if you want more information regarding the project, it's very easy just to put in contact with us with the account of email that you can see in the slide. And that's all from my side. I put in the slide my email in order, if you want to ask me any question regarding the project or regarding that you want to say. That's all from my side, and I'm gonna give the floor for the next speaker, that is Maria del Mar. So the floor is yours. Thank you very much.
Thank you. Can you see my slide? Yes, no?
Yes.
Okay. Good morning, everyone. First of all, thank you for joining us and be here with us. I am delighted to share the exciting progress made during the initial phase of the Project Merlin, as mentioned Francisco before. During this phase, three main entities collaborate together: IRIS, Rovimatica, and PREZERO. We work seamlessly together to achieve our common goal. Our collective journey involves developing a solution to manage consumer multi-layer packaging waste. Each of these entities will now explain our respective contribution to this achievement. I will begin with the IRIS monitoring system, followed by Álvaro from Rovimatica, who will delve into the automation of sorting, pick and place, and visual system. And finally, PREZERO will provide a broader perspective of the current challenges in the common waste management plan in relation with the multi-layer packaging, and how the integration of both parts, the Rovimatica and the IRIS part, has been successfully implemented, contributing to the potential solution. No? No. Now let's delve into the monitoring aspect of our project, that is the IRIS part. But before I get into that, let me quickly introduce myself because I forgot it. I am Maria del Mar Blanes, part of the PMO group of IRIS Technology Solution. It is a small company dedicated to using cutting-edge technologies to make industries smarter and more innovative. Here, now let's dive into the content of my intervention. Today, we will talk about IRIS as a company, then our objectives in this field, the different monitoring technologies used in the prototype, and the artificial intelligence models. And finally, I will talk about the monitoring part of the final prototype developed. Well, as I said before, at IRIS, we specialize in key enable technologies for digital transformation. We are passionate about empowering business with solutions for Industrial 4.0 competitiveness. We are SME, small and medium enterprise, with a significant presence in innovation realm, as evidenced by our participation in over 100 R&D projects, mostly funded by the European Union. The project Merlin is a notable example of that. It can be said that discussing IRIS without mentioning innovation is nearly impossible. We achieve this by adhering to a set of values that I will show you now. We pretend to be inspirational, pioneering, exceptional, determined, integral, and passionate. These are the values that serve as the basis of our commitment to the excellence and success. Then our service and products include real-time monitoring lines, employing optical, and other cutting-edge technologies. The image at the bottom right corner here, I don't know if you can see my cursor. You can see my cursor, okay. So here, you can see two of our main products in this line: the Visual Palm, that is an artificial intelligence assisted handheld near infrared analyzer, and then the Visual hyperspectral imaging system for real-time physical chemical analysis and detection. There are more products you can explore on our website under the product section if you are curious about them. And as I mentioned, our vision or mission is to bring digital transformation to the industry. That is why we also provide services in developing digital analytics and cloud platforms, IoT, and even we have our own innovation lab, as you can see here. All of this allows us to apply our solution to a wide range of industries, from food and recycling to construction, pharmaceuticals, textile, and aerospace. In the monitoring realm, we employ innovative techniques to address quality control requirements, pre-sort materials for recycling, as the case of Merlin, identifying substance purity, and much more. And in our digital solution, we not only provide support for various aspects, such as logistic, process control in industry, but also assist in areas of collaboration, decision making, a marketplace for our regulatory bodies and other stakeholders. Well, now let's focus on the objectives of Merlin Project. Our aim was to create a monitoring system for identifying multi-layer samples. This involved integrating different monitoring system techniques and artificial intelligence models capable of identifying various types of packaging based on their composition, like, for example, polyethylene terephthalate, sorry, or polyethylene terephthalate, or metallizate multilayer films that are the most common, as I can say, packagings in the waste streams. Okay, after rigorous testing, we select a combination of two monitoring technologies. So in the slide, these both. The near-infrared hyperspectral imaging allows us to identify polymers and analyze the multi-layer composition. Simultaneously, the metal detector excels in detecting metallized film, proving to be an optimal choice for this specific application. As its names indicate, the near-infrared hyperspectral imaging is a sophisticated technology that combines two powerful techniques, the near-infrared spectroscopy and the hyperspectral imaging. This combination allows to identify and differentiate materials based on the unique spectral signal, and as an important benefit to aspect to highlight is that it's non-destructive and real analysis, making it valuable for industrial application. Now let's explore the artificial intelligence models that have been developed. It's important to mention that when it comes to monitoring, relying on only a camera signal is not enough. You must develop and train, predictive chemometric models to identify and classify signals according to the model categories. For this purpose, we have developed models for plastic type that you can find here, discrimination. In short, it relies on finding helpful connections in the data to make predictions and classification. That's in a summary way. Then the combination of our efforts leads to the integration of these technologies into a prototype. This prototype has undergone testing at various stages, initially at IRIS, then integrated with the sorting system that Alvaro will explain later, was tested at Rovimatica facilities, and finally we validate it in a real environment at PREZERO facility. In the image, you can see our system on the left and the entire prototype with both integrated components, the IRIS monitoring system and the sorting system from Rovimatica. So in conclusion, that's wrap up my part of the presentation. At the end of the whole session, we will open the floor for the questions. However, if you have any inquiries later on, or feel free to reach out to the email displayed in the screen here. I will be happy to provide assistance to you. Thanks for your attention. And now Alvaro from Rovimatica, as I told you, will take the floor to delve into the sorting system. Thank you.
Thank you so much, Maria del Mar. I will share my screen. Okay. So thank you for all the attendees and also my colleagues at the project in this presentation. I'm going to present today the robotic side of this sorting system, this innovative sorting system that we have developed under the project. As Maria del Mar greatly explained, this is part of the project, of the Merlin project, where the first steps of the project, we could say it was the first work package of the project itself, was to develop an innovative sorting machine to tackle the main challenge that the waste management industry is facing in terms of the sorting, which is quite complex at the moment. So Maria del Mar just explained the monitoring side, where they are able to detect the components or the materials that are part of this multi-layer waste. And we are taking the side in this actual robotic automatic sorting, we could say the pick and place of these waste materials. After going to the point, just a small advertising break. I'm going to explain some things about Rovimatica. Rovimatica is a technological SME that's located in Andalusia, Spain, in the south. Our headquarters are in Cordoba, and the R&D department is located in Seville. We are around 60, 70 people nowadays, and we have collaborated in several projects, several R&D projects. In terms of the development lines or business areas that we have in the company, we are specializing in robotics and all kinds of automations. We specialize also in computer vision, all kinds of applications, not only for the industry, but also for several applications such as health, cybersecurity, trying to get the most that we can from these new technologies, from artificial intelligence or the vision systems. And we have also a branch about special vehicles, which is bringing this robotics and combining with vision and so on to provide specialized solutions in some sectors, such as the thermal energy plants, in infrastructure development, intervention, assessment, and so on. In terms of R&D, the kind of research lines that we have involve, as you may imagine, the main is the industrial one, which is our core business in the company, but we also develop some projects in terms of drones and space, in terms of using computer vision in the in-cabin of vehicles, in agri-food, circular economy, such as this project, and also in terms of infrastructures. Going straight to the project, the challenge that we had was quite clear. It was to being able to pick and sort all the waste, all the plastic waste that needed to be detected in this multi-layer flow, or not even multi-layer, but detecting the multi-layer and after that doing all the sorting. So the challenge is developing a solution that it's able to handle all these materials. So we need to have in mind that there are a lot of different geometries. We have also some films that they are completely flexible, not even rigid at all. So all these three challenges that I'm presenting in this slide are focusing on that part of being able to handle all kinds of materials. The first great challenge was to design an N effector that is able to pick all these materials and to throw them into the required bins for the actual sorting. And in that sense, we started our iterations with different approaches. But at the end of the day, we decided to go with a triple approach where we have three different gripper mechanisms. And based on a vision system that I will describe in the next slide, we are able to tell the robot which gripper needs to use depending on the waste that it needs to pick. So as we can see in the right side of the slide, there are three different parts. We have a needle gripper, mainly for gripping films that can be adhered to the conveyor. They can also be actuated in trays, but after all the testing, we have considered that they aren't strong enough to perforate the thick trays. Also, we have flexible finger grippers. As these days, they are manufactured in aluminum, and they are mainly to grab the trays and rigid materials as a human would do. From the side, we are able to detect the geometry of the tray itself, and we are able to pick it from the side, such as a human would do if it needed to pick this kind of waste. And we have on the third basis, we have the vacuum gripper, which is the most versatile and most utilized system to grip in this kind of environments, and it will be mostly used for films. In terms of the vision system, as I mentioned, all goes into tackling the same challenge, being able to grasp anything. So the kind of knowledge of data that we need to send to the robot and the end effector are mainly what kind of material are we facing? Is it a tray? Is it rigid? Do we consider it flexible? These kind of things will make the decision, will build the decision on what would be the approach to grab these materials. And also we will need, of course, a precise location of these waste parts. And in terms of a more complex way, we need to segment it. As I mentioned, we need to really know the edge of the parts, the contours. We need to know the center of gravity if we are going to use, for example, the vacuum gripper. So there are some different variables that we need to know in order to command the robot on the most optimal way. And on the third part, we have here the demonstrators. As you can see, there are two different demonstrators. I think that we haven't mentioned it yet, but on a first phase of this project, we developed by our own a smaller demonstrator, in this case, to validate the system, the pick and place and so on, and vision system, all the things that I explained. Also in IRIS, they developed the same kind of small demonstrator with a small conveyor and their monitoring system. We were able even to set all the communications in this environment. But the idea is, of course, to bring all together to develop a complete solution. And it's what you can see in the right side of the screen. This was in our facilities where the system from IRIS, they brought them Here, we integrated the whole system, and this is one of the first pictures that you can see of the whole system being fully working. And in that sense, here you have my contact details in case you have any doubts. Also, at the end of the presentations, you can ask wherever you want. And I leave the floor to our colleagues from PREZERO that will present the next step of this integration under Merlin. Maite, you're muted.
Yes, thanks, Alvaro. So, morning. First of all, thank you everybody to join us in this workshop. So we go to move on to the last part of the workshop, where we are going to talk about the challenges and the integrated system as a promising solution. Yeah, Maria del Mar and Alvaro have explained their individual parts of the prototype, and I am going to talk about the validation at our installation. So here you can see the section that I am going to talk about. So let's start with a brief presentation of PREZERO. PREZERO is an international provider of environmental services with around 30,000 of employees, and we are present in 11 countries in Europe and North America. We are part of the Schwarz Group, which includes companies like Lidl, Kaufland, and Schwarz Production. And well, in Spain and Portugal, we have an experience of more than 50 years, and we offer services up to 12 million of citizens, and we are present in more than 980 municipalities. We operate 127 plants, where we treat around 6.7 million of tons per year. So we also provide services to industrial clients of around 8,000 clients, and we are around 16,000 of employees. So here you can see the main fractions we upgrade at PREZERO in Spain and Portugal. So today we are focused on plastic, particularly in multi-layer plastics. As my colleagues Francisco told at the beginning of the workshop, they are widely used, for example, in the food industry, because they provide some advantages in terms of food preservation. So we have a challenge in their recycling, because with current technologies, it's not easy to separate and sort this kind of multi-layer plastics. So we need to innovate and to look for new solutions. In PREZERO, we have more than 20 years of experience dedicated to the development of new solutions to transform the actual models towards a circular model. So according to our innovation lines, we can point out the energy transition and material circularity, apart from other like new business models and operational models. We pay attention to the employee as well, and digitalization is a transversal axis that is included in our line. So Merlin combine these two, the material circularity and the digitalization. We need to look for new processes to try to separate these multi-layer packaging waste. So let's start with our role as PREZERO at Merlin. So our main objective is to provide information about multi-layer plastic waste, both rigid and flexible, along the sorting process for the design of the monitoring and artificial intelligence powered robotic system. So we have developed these specific objectives along the project. So let's start with the first of these, that is the identification, distribution, and quantification of multi-layer packaging material in a waste treatment facility. Here you can see a diagram of one of our plants. But what happened when waste arrived to our facilities? Well, first of all, waste are discharged in our facilities, and they are usually handled by means of a hydraulic grapple. So after that, waste is put in the process, and the process is fed with this waste. So the first step is a size classification by means of a trommel. So we do a granulometric separation with different meshes, and we obtain 4 main streams. The smallest one that is destined to biostabilization process, the 50-200 millimeters that goes to a densimetric separation, 200-300 that goes to a bag opener, and then follow the system to the densimetric separation. And the biggest one that is sorted in a cabin to triage and obtain the usable byproducts. So after that, we do a densimetric separation, and material go to a ballistic separator. And here we obtain 3 main streams. The smallest one that goes with the previous one to the biostabilization step. And we have 2 fractions, the flat waste that goes to an optic separator to sort film, and rollers that go to a wind shifter to remove the remaining film fractions. And finally, we develop a product separation. Ferrous materials are separated in a magnetic equipment, and non-ferrous material, mainly in aluminum, is separated in an eddy current separator. By means of optic separation, we obtain materials like PET, HDPE, mix, Tetra Pak, and solid recovered fuel. So as you can see, we have a lot of streams, but with these technologies, it's quite difficult to sort these multi-layer materials. So we identify 7 streams where we can find this kind of materials. The rigid material are found in the streams 1, 2, 3, and 4 along the process, and flexible material are found in streams 5, 6, and 7. So once we have identified the streams where mainly composed of plastic, where we can find multi-layer materials, we did a characterization. So we are talking about this kind of material since the beginning of the presentation, but what kind of material can we find in these streams? So in the case of rigid materials, we can find multi-layer trays like this one, monolayer trays, and monolayer bottles. And in case of flexible materials, we can find multi-layer metallized film, that are this kind of film or bags, a multi-layer non-metallized film that has an aspect like you can see in the slide, and also monolayer film that in common we can find plastic bags. So, well, yes, we did a characterization of these streams to analyze the composition of them. And with the composition and the mass balance of the process, we decided that the most promising streams where we can find the major quantity or multi-layer materials are, in case of rigid materials, the PET line. Here we can sort the rigid material in this stream. And in the case of film, in the film line, we could separate here the film multi-layer materials. So, well, once IRIS and Rovimatica test their systems in their labs, we developed the validation test of this industrial proof of concept for multi-layer sorting at PREZERO waste facility located in Sevilla. Tests were developed during August and September. And we realized that due to the lower capacity of the prototype when compared it with the industrial treatment line, the system finally was built as a standalone unit in our plant, and test was developed in a batch mode. But we used the materials directly taken from the industrial line. We remember that we chose streams 1 and 5, and we simulated in industrial conditions. So, as I said before, these validation tests were performed at PREZERO facilities. So, specific training sessions with IRIS and Rovimatica were organized with PREZERO personnel to operate the system. And after the startup, some improvements were made to solve problems that appear when the system was operating in the plant. So as you can see in the images, the system is surrounded by a protective structure, but it is open at the top. So some problems as dirtiness, for example, some dust, could to error or mistake in the measurement of IRIS. So some improvements were implemented to solve this kind of problems. For PREZERO, the results of the project are key to advancing the development of innovative technologies to increase the rate of recovered material in our sorting facilities, assuring its quality for further recycling. So we saw that now multi-layer material are being rejected in our processes, or if not, they are contaminant in streams of monolayer components. So it's reduce the quality of this stream and hinder its applicability to produce new products. So some conclusions of our test since the beginning to the validation, we can say that the prototype has operated as a standalone unit at PREZERO's mechanical treatment facilities located in Sevilla, and some improvements have been implemented due to the harsh condition of the industrial environment. The system capacity is around 1 packaging every 3 or 4 seconds, and the identification unit used near-infrared and hyperspectral imaging technologies for real-time analysis of plastic composition, and the integration of a metal detector is pivotal in identifying packaging with metallic elements. From the robotic system, we can say that it's fit with a versatile end effector with 3 distinct gripping mechanisms, and the coupled vision systems intelligence plays a crucial role in determining which gripper is most suitable for the type of waste detected. As Alvaro explained before, it depends if it is rigid or flexible. The monitoring system and the robotic unit have been successfully integrated. There were a very good communication between the two systems. So an innovative plastic sorting solution that automatically sorts multi-layer packaging has been validated. So these promising results are key to implement more effective and efficient sorting procedures to increase the recycle of these challenging materials. So now we are going to see how the system has been operating in our plant. So we have a video to see it.
In the food industry, multi-layer packaging plays an important role in maintaining food quality, preventing contamination and product degradation. However, multi-layer plastic is a material difficult to recycle due to expensive and complex methods to sort and delaminate the packaging. The Merlin Project has put together a partnership to design disruptive processes for the sorting, delamination and recycling of multi-layer plastic packaging waste to obtain new high-performance packaging solutions for the food packaging industry. 3 companies, IRIS, Rovimatica and PREZERO, have joined forces to develop and validate a plastic sorting solution that automatically separates multi-layer packaging waste, improving current quality and recycling rates. Validation tests of the prototype have been developed at PREZERO's waste mechanical treatment facilities located in Sevilla. When waste arrives to the plant, it is fed into the processing line where the different materials in the waste are firstly classified by size and shape through different trommels and ballistic separators. After that, metallic wastes are sorted using ferrous and inductive separators. Finally, optical separators are used to differentiate and sort the different kind of plastic materials: PET, HDPE, PP. In case of multi-layer plastic packaging, current technologies can only identify the superficial layer, so its sorting is challenging. To address this problem, in the frame of Merlin, IRIS has developed a system that utilizes near-infrared and hyperspectral imaging technologies for real-time analysis of plastic composition. Rovimatica has designed an innovative AI-driven robotic system. At the heart of the operation is a SCARA robot, fitted with a versatile end effector that boasts 3 distinct gripping mechanisms: a vacuum gripper, a pneumatic gripper, and a needle gripper. Due to the lower capacity of the prototype compared to the industrial treatment line, the system was built as a standalone unit. Tests have been then developed in batch mode, and the prototype has been fed with materials directly taken from the industrial line simulating industrial conditions. For PREZERO, results of the project are key to advance in the development of technologies that allows waste managers to continue increasing the rates of recovered materials in sorting facilities and assuring its quality is good enough for further recycling. All of this with the goal of maintaining resources in the production cycle and reducing the consumption of new raw materials.
So that's all for my side. And now we can go to the Q&A. You have any doubt or for me or to my colleagues, so we are pleased to answer the questions. Thank you very much.
Okay, I think that there is no question from the audience. Maybe you have any curiosity, any doubt regarding the different technologies in the workshop, or maybe the presentation were very explicative and you don't have any question. I don't know. Yes, Inés Bozalongo have a question. Okay, I want to read it. Sorry. Inés Bozalongo says that what will be the sorting rate for brick packages? I don't know if you want to ask to these questions, any of you.
Yeah, I'm not sure if I'm understanding it well. For brick packages, do you mean, well, I think that Inés, we can also give you audio if you want to talk. I have just allow you the microphone. But at this point, we don't have a differentiated sorting rate depending on the material. The robotic side and the monitoring side are working currently at a speed of 3 or 4 seconds for each waste for the sorting. And that remains for all the different materials. I don't know if that answers your question. You're welcome.
Okay, thank you very much, Ines, and thank you very much, Álvaro. Any additional question from the audience? Okay, I think that's all. So let me conclude with this workshop. Thank you very much for the speakers of the workshop, to María del Mar, to Maite, Álvaro, and Elizabeth. Thank you very much also for the audience, for all the attendees of this workshop. See you in next events regarding Merlin Project or another European projects. And thank you very much to all of you, and have a very nice day. Bye-bye.
Thank you so much. Bye-bye.
Thank you so much. Bye.